packaging. Next, assembly technologies. So wafer preparation, as I told you, 12-inch wafer is well established, and the thickness will be around 650 to 700 micrometer. Okay, so here meter is present, it is not meter, micrometer, 650 to 700 micrometer. That is the wafer size, that circle wafer size. But in that wafer, only 100 micrometer will be used for doing the IC fabrication. Remaining things are extra. 100 micrometer effectively we can do in the wafer, 12-inch wafer, 650 to 700 micrometer size. Okay, in that only 100 micrometer we are able to do effective IC fabricated or dies. Okay, then silicon is the substrate used in this wafer, and thickness of the wafer is also important. How much the dies are separated, each that squares, how much distance is there separated, and then chemical mechanical polishing is done. Okay, and the front side is protected during the while doing IC fabrication. Front side protection, if scratches goes on, then the IC fabricated will get damaged. So without scratching, all these things should take place. Defects, all these things should take place. Here you can see this is the wafer. Each square is called die. Okay, each of this square is called die. Good die, bad die, we will decide. Okay, properly IC fabricated or not after testing. E-test, automatic testing is there, so we will check it. And all these are part of. Then die separation, die pick and place. Okay, so pick and place means good dies we will separate, bad dies we have to refabricate or throw it. Okay, so scribbling means this horizontal vertical lines we have to cut. Horizontal vertical lines we have to cut. So each small square is one IC. A circuit, big circuit is present each of the square. Next, after sorting, after die separation, the plated die, these are different stages how the wafer is cut into small pieces. Next, die inspection. Okay, the small square boxes are ready. Now we have to inspect whether that IC present in the die is properly fabricated or not. Okay, inspection means testing only. So any cracks or defects are there, all those will be done under optical microscope, and it is an automatic process. Then die attach. Okay, now that die is good die. We have decided after testing it is a good die, IC is fabricated well. Now we cannot deliver it to the customer in a loose manner. So we have to attach it onto a mount. Mount means a stand. You can take it as a stand. You are putting this die on the top of the stand. Next, suitable medium. That stand, what type of material? I told you it may be ceramic or plastic. Okay, mount. On that we are putting the IC. Then we are taking pins, legs out of it. So that strong bonding. We have to create a strong. When you take this die and put on the mount, we cannot tell it will get attached. Say there should be some adhesiveness. There should be some gum nature. Okay, when you put this die, it should get attached to the mount. Only then it will not slip away. Okay, so that strong bonding is required. And then in that bonding also we have different types. Wire bonding, tape bonding, all these things. You can see here, after putting it, this is the IC fabricated. We are putting it on a mount. We are taking out pins outside that. Okay, so these are the pins, legs out of all this, and we are connecting them. Okay, those pins are connected to the dies. You can see those dies, different locations in the die. We are connecting it using wires. If we are using wires, that is called wire bonding. Okay, and you can see die attachment continuation. Die is attached. Then bonding means connecting with a wire. Okay, different locations in that IC we are connecting with a wire. Wire or tape. Okay, or flip chip bonding. So 3 types of bonding is there: wire bonding, tape bonding, and flip chip bonding. And then you can see the first diagram. Here we are putting the die, which is a good IC fabricated. Then you are taking a ball and a capillary is connected. And then this is the arrangement, which is called gold wire bonding. Next, ultrasonic vibration. This is the method. Aluminum wedge bonding between the lead and the die. Okay, so here is the lead, here is the die, and then aluminum material wedge is used. This is the wedge bonding. So it is made up of aluminum material. It may be gold wire bonding, aluminum wedge bonding. These are the different methods in the wire bond. That wire is made up of different materials. Next, we are having the solder bump. You can see here, we are having pads. On the top of pads, we will put that wafer or die. Then lead is getting connected and thermod. Okay, so this is another type of bonding. This is the wafer. We are putting it on the top of this pads. These are the pads. You match it with the left side diagram. These are the pads. We are going to put the wafer on the top of the pad. So this is the wafer. We are going to put it on the top of the pad. And then packaging technologies, packaging fabrication technologies. We have ceramic package, glass sealed, plastic mold, improved molding, plastic composite technology. Okay, so already the terminology itself makes you familiar. Ceramic means that outer mount is made up of ceramic material. Glass sealed means we are making it airtight. Okay, so we are making, if two ICs are there, we are going to mount it and we are sealing it with glass so that it becomes airtight. Airtight means contamination is less. Okay, so based on the necessity of the circuit, we will also make it as glass sealed. Next, plastic mounting means that mounting material is made up of plastic instead of ceramic. Improved molding process, improved molding. Plastic composite technology means if complex circuitry is there, then we can also go with the plastic composite material technologies. Next, other special package considerations. Previous is fabrication technologies in the packaging. Next is special considerations in the packaging. So what all we have to give importance? Cleaning process. Every time cleaning is important because the contamination should be removed. It should be prepared for electrical connectivity. Okay, whatever IC finally is available, it should be, before packaging, we have to clean it so that external contaminations are removed and it will be ready for electrical connectivity. Okay. Next, ceramic package, lid sealing, then encapsulation, alpha particle protection, assembly environment, properly whether the individual components are assembled properly. Encapsulation means whether it is giving connections, whether that IC properly it is connected. Okay. Then alpha particle means the materials which are present, any external foreign materials we have to remove or not. Miscellaneous assembly operations. Okay. Any other operations are required or not. So all these things should be special considerations before going with the final packaging. Packaging, these are the technologies in packaging. Okay. So with this, we have discussed